One of the biggest advances in aviation since the turn of the century has been the advent and integration of unmanned aircraft or drones into the military. And right here, we have the Turkish aerospace industry's latest drone, the Anka 3. And in just a moment, it's about to go out for its latest test. This drone's primary goal is reconnaissance, and for that, you need to fly under the radar. Soon, the most obvious characteristic in achieving that becomes apparent. This drone doesn't have a tail. One other new feature for the company is its turbofan engine. But the first military drones developed in the early stages of World War II didn't have engines. The United States produced the first remote-controlled aircraft called the Radioplane OQ-2. In fact, before she became one of the most famous women in the world, Marilyn Monroe worked at the plant assembling these drones. Back on the airfield, it's all systems go. The Anka 3's wheels start rolling. Today's test is going to be the last before its maiden flight, so they're carrying out high-velocity taxiing. While one of the prototypes is out for a spin, I head back into the hangar to get a better look at Turkey's most advanced drone. Ömer Yıldız is an executive vice president of the company's unmanned air systems and tells me about some of the features that makes this drone so special.
We optimized our aircraft, this aircraft, to be less visible in the radar. So that's why we don't have the tails on this one. And taking out the tails makes the aircraft unstable, which makes, in turn, it makes the control quite difficult.
Is stealth technology kind of the prime driver in how advanced a particular drone is? Is that what's driving the technology now?
That's one of the motivation that drives the technology over here. And so there are various ways of obtaining the stealth state capability. One is the adjusted geometry. If you have a nice geometry and if you don't reflect coming back the RF waves, then you maintain the low radar cross sections. Our first aim is to solve the geometry, then address the other problems afterwards. And solve geometry, solve the flight control problem first.
You're kind of seeing a morphing between drones that are beginning to resemble fighter jets. There seems to be more of a convergence in the appearance.
We're getting close to fighter jet, but our purpose on this aircraft is not to dogfight, for example. And this is optimized for air-to-ground ISR missions and air-to-ground missions and deep strike missions. So with this plane, we'll take over the air-to-ground missions of the F-16s, for example.
When developing a model such as Anka 3, how important is it that it can communicate, work with other models that are being developed on this campus?
We are developing on this aircraft, Anka 3, on the heritage of the Anka 1 and Anka 2, actually. We're using a similar, some are the same, some similar avionic equipment, for example. We can fly both our three aircrafts, Anka 1, Aksungur, and this one, from the same ground control stations. So this is one commonality. The second commonality, we also on Anka, for example, we can do the joint operation with the helicopter. This aircraft will also have the joint operation capabilities. And besides that, this aircraft will fly as a loyal wingman besides the Kaan Turkish fighter. And we have our smaller target drones. They have started as a target drone, but they will carry out some other missions as well, the Super Şimşeks. So together, all these airplanes can work, cooperate, and act like a swarm in the mission.